Hello, welcome to another pre-calculus lesson with Professor Checo. Today we'll be focusing on lesson 3.2, compound and continuous compound interest. So let's go ahead and let's get started. Alright, so as you can see we have 29 questions. And as always I'm going to go straight to the textbook just to see if I need any formulas and so forth. Alright, let's scan through this. So compound interest is if at the end of a payment period the interest due is reinvested at the same rate, then the interest as well as the original principal will earn interest during the next payment period. Interest we'll call it like this is called compound interest. And that's going to be this formula, boom. So here we have numbers of quarters, so where's my actual formula? There we go. Compound interest formula is 1 plus the interest raised to the n, where I is the rate per compounding period and n is the total number of compounding periods. I'm just using the formula. So here, continuous compound interest formula is principal times e raised to the RT. Just going forward, moving forward, looking for formulas. Conceptual, if we solve this, we solve for that. Oh, that's just to solve it with ln's. Okay, so the annual percentage yield, the APY, is 1 plus the rate divided by m, where m is the times compounded m times per year divided by m minus 1. Okay, if the principal is invested at the annual rate, then it's that. Okay, so that's to find your APR, which is again the what annual percentage yield. The annual percentage yield is referred to the effective rate or true interest rate. Okay. That is it. So we have those three formulas. Let's get into this. So solve the equation for the unknown quantity, divide both sides, take the ln. Is it ln or e? Once you get the two bases to be equal, yeah, you get that. ln, yep. And then that brings it down, and then you're able to solve that. Okay, that's just review. So here, use the compound interest formula. So let's go to view an example, get this compound interest formula, which is p times 1 plus I to the n. So let's just do this. It's going to be, what is that, 500 times 1 plus the rate, which is going to be 0.077 raised to the n. So it should be up there, which is going to be 29. Let me just view an example, confirm that I have the right formula, principal plus 1. I'm pretty sure this is going to work. So let's say that it's going to be A, should be 4297.59. Cool. Just plug it into the formula. Awesome. Alright, here you're plugging in and solving for A, working backwards. Probably involves an ln in there. But I think it's pretty straightforward. Yep, pretty straightforward. Here we go. This is continuous, which is going to be a different formula. That's going to be PERT. So now for this one, it's going to be 7,000 e raised to the r times t. My rate is 0.0715 times. No, I got to do parentheses up here. Parentheses times the t is 2. So that is going to have an annual 8076.11. Cool. So now I've used both formulas. That should be pretty straightforward. Here you're going to be solving backwards, and then obviously if you're going to be working backwards with e, that'll be ln. So this problem just involving ln. Pretty straightforward. Solving for t, solving for the exponent, going to have an ln. Pretty straightforward. Solving for the r, pretty straightforward. Given the annual interest rate and the compounding period, find I, the interest rate per compounding period. Now let's find this. So it's compounded quarterly. Given the annual interest rate not sure. What is this asking for? You just take the rate divided by m. Oh, that's it. So for this question, it would be 0.039 divided by 4. Oh, I could have just done 3.9 because it wants it as a percent, and that would have been 0.97, 0.975%, round to nearest decimal, or 10 nearest thousandth. There you go. That's it. Got it. Boom. Okay. Given, so monthly divided by 12, per half year divided by 2, per month divided by 12, divided by 4. All right, let's see. If this is invested at 3% compounded quarterly, so that would be, I believe, this divided by 4, or is it raised to the 4? Let me just take a quick peek. Yep, so it's our original I. 4% compounded quarterly. So first I have to figure that out. I gotcha. So this one would be 4,000 parentheses 1 plus this number 0.03 divided by 4 raised to the 10 years. I think. Let me just double check that. And total number of compounding periods. Do I have to multiply n times 4? Yep. So this is going to be times 4. Let me do a parentheses and then times 4 for the periods. And then this money is going to be 5393.39. Cool. So here is our compounded quarterly, 10 years. Awesome. Pretty straightforward. All right. So now here, what's the formula? Compounded continuously. PERT. And you just plug that in. Rate is that. T is that. So 7. Yeah, you got it. Oh, there's 2 steps to this. Let's just take a peek. 7,000. My rate is 0.03, and my time is 4. How much would it be? Oh, just find how much that would be. Cool. Moving on. Yep, I'm skipping it. Alright, discuss similarities and differences to the graph of future value A as a function of time if 1,000 is invested for 8 years and interest is compounded monthly at a rate of 4% and 8% and 12% respectively. Similarities of the graphs they all start at $1,000. Graph A is 4%, increasing as t increases. The difference is the rate of the value of A increases depending on which value depends on the value of the annual rate. There you go. We're comparing these annual rates. The steeper, the more interest you're getting, the more money you'll be making. All right, an investment company pays 6% compounded semi-annually. You want to have $4,000. How much should you deposit now to have that in 5 years from now? So I'll write the equation. That's going to be 14,000 is going to be equal to our principal, and then so then our equation would be 1 plus 0.06 divided by 4 raised to the 4 times 5, so that should be 20, right? Okay. Now when you do 1 plus this raised to the 20, this is going to give you a number. So if I just do that, and then it should be my initial 114,123 divided by, copy, Control V, equals, that means I'm going to have to invest $10,394 and 59 cents. 10,000 semi-annually. 2, 10. I think that's the only reason I messed up. Let's take a look at that. $10,417.31. There we go. Sorry, I messed that up. Semi-annual means 2. Okay. All right. So how much should you deposit now to have that amount in 10 years from now? So same thing as like question, just changing the T, working backwards, moving on. That's the last part. Okay. All right. What is the annual percentage APY for money invested at an annual rate of 4.7 compounded monthly? I'm gonna need the equation. I forgot what So here, my equation is going to be. Let's just write that down. APY. So let's do A equals 1 plus R divided by M raised to the M minus 1. Right? So that's my equation. That's to find that number. Okay. So now here, if it is, I should just be able to find it. This is just like plugging in, right? Parentheses 1 plus the rate, which is 0.0475 divided by compounded monthly should be 12. Not 120. 12 raised to the 12 minus 1. I gotta delete that. And so that should be 4.8548. 3 decimal places, 1, 2, 3 seconds. I'm gonna go up to a 5. Awesome. Yep, that's gonna be the equation. 4.56 quarterly. That's just gonna change to a 4. This one's gonna change up here to a 4. And this one's gonna be 4.835%. Quarterly is not 4. Oh, I didn't change the rate, right? 4.7. There we go. 4. Sweet. Cool. Moving on. Yep, these same exact questions. Alright, now how long will it take $2,000 to grow to $11,000 if it's invested 6% compounded monthly? So you would have the equation, figure out how that's going to be equal to. There's the equation, plug everything in, solve it, yep, divide, boom. Figure out how to use ln. Pretty straightforward. How many years will it take for an investment to reach of $10,000 to grow to $35,000 and assume the rate of 9% compounded continuously. Compounded continuously is going to have E, so that's what, principal ERT, plug it in, boom, done. How long will it take the money to triple if invested at the following rates? So this one's actually pretty thin because like when you divide your A divided by P, it's just going to be 3. So here it's double. So it's double. So then it's just, A equals 2P. So when you divide it, you get that ratio. See? And then it's just you divide it, you get it 2. That's the only tricky part. Everything else pretty straightforward. Compounded quarterly, compounded quarterly. How long will it take money to double if it's invested at 6% compounded continuously? Compounded 8%. That's going to be with E. Yep. A newborn child receives $5,000 gift towards a college education from the grandparents. How much will the $5,000 be worth in 18 years? If it is invested at 5.9% compounded quarterly. One question, pretty straightforward. Rental costs space have been going up by 7.5% a year compounded annually for the past 7 years. If the office space is now $24 per square foot per month, what is the rental rate 7 years ago? Ooh, rate 7 years ago. So now you want to work backwards. So then you're looking for the principal. Let's see if we can figure this one out. So this one's going to be 24 is equal to, we don't know the principal, so I'll put P. And then the equation I'm going to do compounded yearly, so I think it's just 1 plus r raised to the t, parentheses 1 plus the rate, which is 0.075 raised to the shift 7. And if I put this as x, let's see if this works. 14, 2 decimal places, 14.47. There you go. You plug in the equation, work backwards, solve it, awesome. Alright, so now here, is it the same exact equation? This one's with E. So if you pay 25 for the note now, what rate compounded continuously would you earn? So a promise note will pay 45,000 at maturity equals 25,000 e to the y times, oh, I gotta do parentheses up here, times how many years? 11. Oh, this is gonna be really, really, really hard to see. And then I need to intersect this with x equals 0 because it is so small. .343. Dang, I gotta work backwards. So yeah, we'll just take this divided by that, use ln, solve for that. Okay. Yep. If you save $7,000 towards the purchase of a car costing that much, how long will the $7,000 have to be invested at 7% compound monthly to go to 21,000? Well, it would be compounded monthly, so then it would be this formula, and then you just plug all your values in and you figure out how much it would take. And that's the second part, so all good. Yep. An IRA account has 21,000 in it, and the owner decides not to add any more money to the account other than the interest and earn the 7% compounded daily. How much will the account 340 how much will be in the account 40 years from now when the owner reaches retirement age? So 365 day year, and then you just take that, plug it in for the equation, this one I, and you just plug it in. Cool. And that is the only part they want, so I'm gonna keep going. What is the annual nominal rate compound daily for the bond that has an annual yield of this? What is this equation? Okay, this is when you have to subtract, so then you would just take the R is the annual nominal rate. So you'd have to work backwards at this point. I gotcha. Had an annual yield of 4.4%. We'd work backwards to find the rate. So we have this, we have the months. Okay, and you just gotta work backwards to find it. Okay, pretty straightforward. And that's the only part. Okay. A zero coupon bond is a bond that is sold now at discount and will pay its face value at some point in the future when it matures. No interest payments are made. A zero coupon bond has a face value of 20, matures in 10,000. What should this bond be so that it, okay, so let's take a look at this. So the equation I'm going to need is that how is it compounded? Compounded semi-annually. Semi-annual meaning 2. So that means that my equation is going to be $23,000 is equal to this is going to be the principal times 1 plus the rate. My rate is 4.049 divided by 2 raised to the 20. I believe it's going to be raised to the 20 because it's 2 times 10. If I go like that, I gotta zoom out now. I'm looking for my blue line. That's not the purple. My blue line's gonna be a lot more money. It's gonna be like in the 20,000s. There it is. What is that? 14,100. Let's take a look at that. Let's try if I invest $14,173.87. Sweet. So there's your equation, or you could work, this gives you a number, that raised to that will give you a number, divide both sides, and you'll get that number. Okay? And that's the last question. Alright, so I may have skipped a lot of questions, but as you guys saw, they're very repetitive. We're using the equations. The view and example was there for all the questions, so if you get stuck on once you have the equation, solving backwards and solving the equation should be straightforward. Alright, wish you the best of luck.